Chapter 1, Lesson 4 of Pre-Calculus. We're going to look at now building functions from functions. So we've talked about the 12 basic functions that we've looked at in the previous lesson. Now we want to look at different ways that we can build new functions from those 12. And we can do that by combining these functions algebraically, or we can compose functions, and then we'll look at how do we look at relations implicitly, or implicit relations that are given to us in the form of algebraic expressions. Now, when we combine functions algebraically and compose functions, we're going to be creating these new functions. And one of the main things we have to remember about this is that because we're creating functions from functions, the domain of the new function is going to inherit some of the characteristics of the original functions. It's kind of like a mother and a father. They have a child, and that child has some of the characteristics of the mother and some of the characteristics of the father. Both mother and father are combined into one. And with these new functions, it's the same thing, or the same idea, is that we have a function that we begin with, let's call it the mom function, that has a certain domain, and then we have the dad function that has a certain domain, and from those two we combine them and get this new function, or the child. What is the domain of the new function? We can't look at the child independent of the parents. I mean, the child just didn't pop out of nowhere. It took a mother and a father to make the child, and the characteristics of the mother and father that are in the child. And in the functions, we have a mom function, a pa function, ma and pa function, and they create this child function. The domain of that new child function is going to have some of the characteristics of the mother function's domain and some of the characteristics of the father function domain. And so we're going to need to know or look at how we're going to do that. So that's probably going to be the most difficult part of this lesson, is recognizing and understanding how to do those domains of these new functions that we're getting from these parent functions. So combining algebraically, we have 4 algebraic operations. We can add, we can subtract, we can multiply, and we can divide. And just like you can add numbers, you can add functions. Just like you can subtract numbers, you can subtract functions, multiply functions, divide functions. So if you're taking an f function and adding it to the g function, you're simply taking the f of x function, all of its terms, and adding it to the g function, adding it to all of the terms. Now that one's probably not going to be too difficult. F minus g is the one where we'll make most of our mistakes, is because we have to remember it's minus the entire g function. So I would suggest you use parentheses when you're substituting in to make sure that that negative sign goes to every term in the function, and we'll do some examples so you see what I mean. The multiplying the function, you're simply multiplying the entire function times the entire function. And then when you're dividing function, it's f divided by g of x. And again, because we have a fraction, this denominator function, whatever it ends up being, is going to create restrictions in that new child function, because this g function cannot be 0 because it's in the denominator. So when you're adding, subtracting, multiplying, and dividing functions, it's very much like just adding, subtracting, multiplying, and dividing numbers. Now, how do we figure out the domain of the new function? The domain of the new function, because it's inheriting characteristics of both, is going to be the intersection of the two domains of the original functions. So what I usually do, and I'll show you an example, is I figure out the domains of the mom and pa first. And then I imagine, or I actually draw it out on a little number line. What's this domain of the ma function? What's the domain of the pa function? And where they overlap, that's going to be the domain of the new function. And the domain of the new function is going to be completely dependent upon that. You cannot look at the child function independent of its parents, otherwise you're going to come up with the wrong domain, and I'll give you an example of that later as well. So here we have two functions. F of x is x squared, g of x is the square root of x plus 1. And again, what I like to do is to determine the domain of each one of these first. So the domain of this one's going to be all real numbers, because there are no denominators and there are no radicands. And the domain of this one is going to be anything greater than -1. Again, you take this radicand underneath, x plus 1, set it to greater than or equal to 0, and solve it. So now let's go ahead and add these two functions together. So the f function is x squared plus the g function, which is the square root of x plus 1, and I cannot simplify this any further, so that's my answer. Now, what is the domain of this function? The domain of this function is the intersection of this domain and this domain. So let's imagine, like I said, I like to imagine this on a number line. If we're looking at this domain on the left, it's all real numbers. If we look at the domain on the right, it's only from -1 up to positive here. Now, where do they overlap? Well, they overlap from here on up. None of these numbers down here are in this domain. So none of these numbers here can be in the domain of the new function. So the overlap is from -1 up to positive infinity. So the domain of this new function is going to be from -1 and up to positive infinity, because that is the intersection of the two parent domains. All right? So that's how you determine it. And for all algebraic combining of functions, it's the intersection that you're looking for, and you need to make that clear. For all algebraic combination of functions, the domain will be the intersection. When we compose functions, that's not an algebraic building of function. That's a whole different operation. So when we do those, determining the domain is a little bit different. But with all algebraic functions, or combining a function, the domain of the new function is the intersection of the two original functions. All right? So a word about domains, and as I've talked about, the domain of the new function is not necessarily determined by looking at the function. And I'll show you what I mean. It's created from the intersection of those original functions because it carries the characteristics of the parents. We have f of x is equal to x squared and g of x is equal to the square root of x plus 1. The domain we already calculated as this and this, so we have that. So now we want to multiply the g function by itself. So we're going to multiply g of x times g of x. So we're going to take the square root of x plus 1 times itself. Now, when we square the square root, it's going to end up being x plus 1. So g times g of x ends up being x plus 1. Now, if we were just to look at x plus 1 and say, what's the domain of x plus 1? Well, we would come to the conclusion that the domain would be all real numbers because there is no denominator and there is no square root. But that would be considering this child function without considering the parents from which it came. And because this is going to inherit or keep some of the characteristics of the original domain, I still want to look, and I still must look at the intersection. So while looking at the function might cause me to believe that the domain is all real numbers, if I look at the intersection of the parents, I'll realize that it's not going to be that, but because it's the intersection, if I put, let me just draw a picture, if I do from -1 on up, and its intersection with -1 on up, what is the intersection? Well, the intersection is going to be from -1 all up. So the domain of my function is from -1 to positive infinity. So you can see how we can get the wrong domain if we consider the domain independent of our parents, and we don't want to do that. We must consider from where the function came from, and then to consider the domain using those characteristics.